Okay, so next up on the agenda, we have three students who are supported by the Ohio Space Grant Consortium. And I'd like to introduce Dr. Gary Slater.
Good afternoon. I'm happy to introduce a few of our students from Ohio, the University of Cincinnati. When I was going to ask to introduce them, I asked them to give me a short bio so I could read it. And they gave me this piece of paper. It says, Bryan Brown is a senior at the University of Cincinnati. Kevin Davis, Andrew Puterbaugh. Yes, they are all seniors in aerospace engineering at the University of Cincinnati. Three of our distinguished students. I do want to pass the presentation on them, but I want to mention a fourth student who is not here, who really was sort of the genesis. Well, he was at the very beginning. Rob Shavat was an undergraduate space grant scholar for 2 years at the University of Cincinnati. He then followed on as a master's fellowship student, and he really led the project for years along with the faculty advisor, Professor Kelly Cohen, with a small research initiation grant that we gave to Dr. Cohen. And the result is the Sierra project, which these students will be more than happy to talk to you about. So, Bryan?
Thank you, Dr. Slater. All right, my name is Bryan, and I'm with Andrew and Kevin. We're going to present Sierra, the Surveillance for Intelligent Emergency Response Aircraft, or robotic aircraft. Sierra is a project that not only it takes a UAV and combines it with fire prediction software to be able to help fight wildland fires. As Dr. said, we worked with our principal investigator, Dr. Kelly Cohen of the University of Cincinnati, and also Dr. Manish Kumar of the University of Toledo. All of our work was done with the West Virginia Division of Forestry. We'd like to thank Roger Osborne, who is our main contact. The Ohio Space Grant has given our group, or the Sierra, a $15,000 seed grant, which led to the 2 demonstrations that we had in West Virginia, along with another $800 to develop a platform Sierra Lite. As Dr. Slater already mentioned, we had Rob Sharp funded for 2 years under his undergraduate, and then another 2 years for graduate studies. The educational impact that Sierra has had includes 10 undergrad research, and another 5 graduate students have done research under Dr. Cohen. The main focus of Sierra is the interaction between academia and an operational unit tasked for fighting wildland fires using a UAV, with the end game of hopefully having a mini air force of UAVs that can be used by those firefighters. On July 3rd, 1994, a fire was reported in Glenwood Springs, Colorado. For 3 days, they were trying to fight the fires, and with no luck of actually extinguishing it. On the afternoon of July 6th, the fire moved towards a steeper slope where the firefighters were trying to fight, flanking it. Within seconds, the flames went up the hill, and actually 12 firefighters lost their lives. This is the main motivation for Sierra, is to reduce the loss of life by using a UAV which can monitor the fire along with the firefighters and use predictive software. As UAVs have become lower and lower in cost, we've realized that they're easily replaceable and human lives are not. To really get into the study of fire science, we had 2 students, Rob Sharvat and Philip Italiano, actually went and attended a field firefighting training. This led to great insights on how wildfires are actually fought. Using the GPS data and video data collected by the UAV, we can then integrate it with weather, topography, and fuel models to be able to predict how the fire is going to grow. And then this also leads to a greater decision-making. The outlook of the UAV is to use a 5-pound UAV, which is hand-launched, having a ground station that is point and click. All you have to do is just click on a point and the UAV will follow that track, making it as easy as possible for firefighters to use. The GPS and the video can be used to monitor the fire's progress, along with the fire prediction, which will allow for improved efficiency on. All of this really entails to a improved situational awareness. As right now, I'm going to introduce Andrew Puterbaugh, who will talk about the events that Sierra has done. Andrew.
Thank you, Brian. This first trip was to Georgia in the spring of 2011. It was to demonstrate and train our personnel on the operation and the capabilities of the Zephyr aircraft that was funded by the OSGC, which eventually led to us being invited to attend a prescribed burn for 36 acres in West Virginia near Morgantown. The West Virginia Division of Forestry invited us to test and demonstrate the system. Not only did they really like what they saw, it also gave us the opportunity to understand the capabilities of our own system and what we needed to test in later events, such as, in this picture you see on the top, that is the autopilot software. It's the point and click. You right click on anywhere on the map and right click anywhere else, and the aircraft has the capability to follow that no matter how many waypoints you can put. And once it's there, it will loiter and monitor the situation from whichever altitude you specify. The second demonstration flight was a static test with just one rather large bonfire, and this is near Gallipolis, Ohio, but still in West Virginia. And this is in December of 2011. Over here you can see the end user observing the software as it records the video here, in which you can see clearly the fire, the firemen around it, and the smoke it generates. Also at this event, we had the Discovery Channel there present to film for their show Daily Planet, which was then featured in an episode in 2012. In addition to being on the Discovery Channel, we were also featured on the BBC as well as local TV. More recently, we were featured in the Firehouse Magazine March issue, which is the trade magazine for firefighters. This clearly indicates that our project is being viewed well outside the circles of academia and is garnering interest from the end user that we're trying to target. Next, I'll hand this over to Kevin Davis, who will talk about more recent research initiatives.
Beyond just the initial contribution that OSGC gave to the Sierra project, a lot of ancillary research has been developed just because of all the interest in this program. For example, Sushil Garg, one of our master's students, did some amazing work in the field of filtering out the smoke, which is obviously a major issue when you're trying to film a forest fire from above. The vast quantities of smoke make it difficult for the computer to pinpoint where exactly the fire is and what direction it's spreading. Using an orthogonal decomposition method, he was able to remove much of the smoke from the video feed in near real time. As you can see below, just a sample of freeze frames from a video before and after the processing. So that's some amazing work he's been doing. Additionally, Jutsi Argwal, another master's student, has been doing some great work in the field of improving our fire algorithm as far as the prediction aspect goes. Her work focused in analyzing the fuel. There are some great programs out there, most notably Farsight, which analyzes where exactly the fire is going to spread. However, programs on the market currently require a large amount of expert user input, whereas someone trained in the field of forestry fires needs to input the topography, what type of vegetation is there, and obviously we can't have, it takes far too much time to be practical. So Jutsu's work focused in developing a system that takes the video feed from our UAV, and from that it sends it through a fuzzy logic algorithm to determine on its own autonomously what type of vegetation there is, the relative dryness, how quickly the fire is going to spread through that vegetation. This goes through an iterative loop of once it finds the ignition point and generates the fuel map, it runs it through the fire algorithm, watches the fire spread, and can create a very accurate model of how this fire is going to spread, which is obviously of great use to firefighters. Additionally, in addition to the software, we've been working on a new physical platform for Sierra, moving away from the flying wing design to a more conventional slow flyer aircraft. This allows for a longer loiter time, clearer pictures, more payload. It's also a lighter aircraft in general. The main point of this, though, is it was all indigenous to UC, no external companies. It was all designed and built fully by students. The previous system was also hand-launched, which we weren't entirely happy with, just due to it being a bit unsafe and not repeatable. It also took quite a lot of practice before you could properly launch the system. This system here is an elastic launch system, was designed to remedy those problems. It's fully backpackable, breaks up, and can be carried through the wilderness no problem, and set up in any clearing to launch this UAV from. So again, it's just repeatable, reliable, and safe, which is what we want this product to be. Another major issue in large forest fires is obviously the tremendous heat generated, much of which can damage the electronics and the actual structural components of the aircraft. Ryan Hasselbeck has been working on a temperature response controller via a thermocouple, which senses the temperature and can actively avoid these hot spots to prevent damage to the aircraft. But what's really important is the next steps of this. Where are we going to take this product? We're continuing to work with the West Virginia Division of Forestry and a local company known as Adaptive Computing to bring all the technology in-house. We currently use third-party ground station software and hardware. We want that to all be our own. There's no black boxes in the program. We know exactly every aspect of it and can modify it as needed. So we're working with the Department of Agriculture to secure more funding for this ground station proposal. Another big focus we want is to continue to use the many brilliant students we have at UC to improve the algorithms for the autopilot, for the fire prediction, and for our new hardware that we're designing. So I think we have a great product and one we hope will save lives. Any questions? Yes, sir. The question was regarding wind restriction as far as the UAVs go. With small aircraft like this, wind can play a very big factor. And yes, it is still a factor. That's part of the reason why we're switching to the conventional design as opposed to the flying wing design. It's much more robust in terms of the actual wind, but as well as the thermal wicks that can be generated by these fires, which are quite substantial. So no, since it's a very small aircraft, still there is a good deal of impact the wind has. but we are actively working on improving that.
You said you have predictive software. Where are you performing your processing? Is it on the board or is it?
Our ground station that we currently have, he asked if where we're performing our it's actually on a laptop that we use as our ground station. It runs it through a MATLAB code. He was asking what kind of video specifications we currently use. For the first one, it's just a general little camera that you can buy off the shelf. It's what we actually need. It's not very much. We can use since we're limited on the weight, we need to keep it as small as possible. So our resolution is a little low, but it doesn't affect our processing. He asked if we were pursuing multiple aircraft. It is. What the Division of Forestry is looking for is aircraft that we can send up. You have a small team, you can send them, because West Virginia has a lot of open area and they have a lot of fire issues. We're just hoping that having them have a small air force will definitely help in making sure that they save lives.
Okay, well, thank you. Well, that concludes the student presentation portion for today. We hope everybody on the Digital Learning Network will join us tomorrow at 2 o'clock, and we'll have some more student presentations. Thank you.